Okay, last part for this section is kind of going back and forth, not between coordinates now, but going between the polar equations and rectangular equations, or vice versa. The first one we're given, we're told to take r squared and take it, well, that's in polar form already. So we're going to do our best to make it into a rectangular. So we got r equals 2. Thinking about what we know about a relationship between our rectangular and polar, we know one equation is x squared plus y squared equals r squared. If we start plugging in what we know, we got x squared plus y squared equals, we know what r is, it's 2. So we got x squared plus y squared equals 2 squared, which just gives us x squared plus y squared equals 4. Taking a step back, r equals 2, that just really is describing a circle with a radius of 2. So it's not any specific point, it's an entire circle of points. Now b, we've got an angle measure of pi over 3. Thinking about what we know, going from polar to rectangular, we know tangent of an angle is equal to the y value over the x value. Plugging in that angle, we know the tangent of pi over 3 is equal to whatever that y value is over whatever that x value is. Again, going back to the unit circle, tangent at pi over 3. So we find pi over 3, that's over here, so up here. The tangent is just the square root of 3. So we have the square root of 3 equals y over x. Now we could just leave it like that. Let's just put it back in a form that we're a little more familiar with. If we multiply both sides by x, we end up with the square root of 3 times x equals y. So we have y on one side, x on the other, gives us just those coordinates. Now for the next one, r equals sec of theta? What is that? That's the secant. We haven't talked about secant in a while. Thinking about what we remember about secant is the reciprocal of cosine. So secant is the same as 1 over the cosine of theta. Okay, that doesn't help us get from any rectangular stuff to any polar stuff. But what we know now, going back to the previous page, cosine of theta, we happen to know is 1, cosine of theta we know is x over r. Okay, so now we have a polar coordinate in there, right, and a rectangular coordinate in there. Let's clean it up a little bit. R equals 1 over x over r, that's the same as 1 times r over x, or in other words, just r equals r over x. We're trying to get just rectangular coordinates here. We're trying to get rid of r. What I would suggest you do is make them both fractions. If you got fraction on one side, might as well make them both fractions. If we multiply both sides by x, we end up with xr equals r, but then to solve for x, we're going to divide by r on both sides, which would give us just a grand total of x equals 1. Another way you could look at it, going back to this specific setup here before we started simplifying it, we had r over 1 equals r over x. Well, the 1 and the x are in the same position. They have to match up, so 1 has to be equal to x. Last one, y equals x squared. Let's plug in what we know. This one we're given a rectangular equation. We've got to convert it into polar. Y we happen to know is r times the sine of some angle theta. X is r times the cosine of some angle theta. Now the challenge here is we're not dealing with y equals x, we're dealing with y equals x squared. So in other words, we got to square that whole side there. We got r times the sine of theta over here. Now r times the cosine of theta is squared. That's just one big old term there, so we can really distribute that squared to both parts of the same term. If there were different terms, you can't distribute the exponent, but if it's just one term, it can be distributed to all the parts of that term. So we end up with r squared times cosine squared of theta. Remember, that's kind of a goofy notation there. You don't do cosine, well, you could do it as cosine of theta squared in parentheses, but more commonly we'll do cosine squared of theta. They mean the same thing. It's just a little less writing to do it on the way on the right. Now cleaning this up a little bit more, we got r on both sides of the equation. So let's divide both sides by r. So it's going to cancel out that r, and it's going to cancel out that r, but only one of the r's there. We got sine of theta equals r times the cosine squared of theta. Just cleaning this up a little bit more so we have the variables on opposite sides, let's divide both sides by cosine squared of theta, and we'll leave it as sine of theta over cosine squared of theta equals r. For now, I'm okay with us going or leaving it at that spot. If you want to go further, you could break it up into sine of theta over cosine of theta times 1 over the cosine of theta, just kind of breaking apart that denominator, equals r. Sine of theta over cosine of theta, sine over cosine is tangent of theta. 1 over cosine is the secant of theta equals r. So that's another acceptable answer. You don't have to go that far.